Hello everyone, in this video we will complete the topic layers of atmosphere. We have already come to know the structure of troposphere and stratosphere. Stratosphere is also known as ozonosphere because of the maximum concentration of ozone in that layer. Now we will move to the next layer. So today we will discuss about mesosphere. Mesosphere is extended up to around 90 km from stratopause. Pressure is very low in that layer and the air pressure decreases from about 1 millibar at 50 km altitude up to 0.01 millibar at the elevation of 80 km. And above 80 km, temperature again begin to increase with altitude. And this inversion is referred to as mesopause. So in this region, noctilucent clouds are observed on the summer nights over the high latitudes. These noctilucent clouds are formed because of meteoric dust particle and high level convection. Next layer is thermosphere. In that thermosphere, atmospheric densities are extremely low. Main element of thermosphere is oxygen atom and nitrogen molecules. Above 100 km, they absorb solar radiation, cosmic radiation, and by separating negatively charged electrons from neutral oxygen atom and nitrogen molecules, the atoms or molecules become positively charged ions. Term ionosphere is commonly applied to the layer thermosphere due to dominance of ions in this layer above 80 km. And the aura borealis and aurora australis are produced by the penetration of ionizing particles through the atmosphere from about 300 km to 80 km, particularly in zones about 10° to 20° latitude from the Earth's magnetic poles. And due to absorption of solar radiation by the ions, the temperature again increases in this layer with altitude. At the altitude of 200 km, temperature reaches about 700 degrees Celsius. Temperature in the upper thermosphere and exosphere undergo wide diurnal and seasonal variation. They are higher by day and also higher during the sunspot maximum. D layer reflects low frequency radio waves, but it absorbs medium and high frequency waves. And being closely associated with solar radiation, it disappeared as soon as the sunset. E layer, it is also known as Kennelly heaviside layer. It reflects the medium and high frequency radio waves. It is produced by ultraviolet photon from the sun interacting with nitrogen molecules. This layer also does not exist at night. Next layer is sporadic E layer. This layer occurs under special circumstances, and it is believed that this sporadic layer is caused by meteors and by the same process that causes aurora lights. E2 layer that is extended from 150 km onwards, and it is produced by the ultraviolet photon acting upon oxygen molecules. And it appears in daytime and vanished at the sunset. Next one is F1 layer. This layer is important for long distance radio communication. It reflects the medium and high frequency radio waves. Next one is F2 layer. F2 layer, it is almost like F1 layer and it is very important for long distance radio transmission. And this layer is characterized by diurnal as well as seasonal variability. and it is also appears as directly related to the sunspot activity. Next layer is G layer. It is extended from 400 km and above. Free electrons are produced in this G layer because of the interaction of ultraviolet photons with nitrogen atoms in this layer. The next layer is exosphere and magnetosphere. The exosphere is the outermost part of the Earth atmosphere. It is lies beyond 400 km. At such a great height, the density of atmosphere in that layer is extremely low. Atoms of oxygen, hydrogen, and helium gases predominate in that outermost region. And beyond 2000 km, ionized particles increase in frequency through the exosphere, which is known as magnetosphere, where only electrons and protons prevail, and where the Earth's magnetic field ends, that is called magnetopause. Pause means we know the ending. This magnetopause is the upper limit of the Earth atmosphere. So that's all about the structure of the atmosphere. Thank you.